Okay. I guess we're live. I think so. Let's check the volume. Testing, testing. 1, 2. Sibilance. There's a big delay. I hear my mouse click. Okay. Oh, there we go. We're live. Alright. I'm the only one watching myself. How intriguing. Alright, let's fire this up. Start. I wonder if I can get this up a little bit higher. This is a really terrible camera, I apologize for anyone who's watching. It's the old original eyesight. But what we're going to be working on today is this right here, which is so I've been working on this for a while. I have the plastic frame all printed, so I'll turn off what's not printed. Basically all these little fan blades here. I've started printing a version of them, which is over here. Let's cut to the camera. Pop this off the mount. So, these are printed in red because it's just an available color I have. And the electronics that I got from AlexPlusLEDs.com will slide into these slots. And I'll pre-print this once I have the design finalized in black. And put some reflective tape in here so it's a little bit brighter, and then I just have to tape color filters on the outside, and this goes inside the helmet on the sides, you see here in 3D. So I'm using Maya for this. 2012. You can use any 3D program to make 3D printed stuff. I learned this in school, so this is what I've been using. So I'm keep closing that. I'm technically done with the frame. There's a few tweaks I'll need to make based on the one that I printed. But for right now, I'm going to be working on the sidebars, which are these guys here. Fire them up. Grab the camera. How well it's gonna work. Just to cut. So the camera doesn't like it. Yeah, we'll turn them off. Easy to see when they're off. So get a light on this. So these are the sidebars. They basically go on the sides of the helmet. Near the chin pieces. I guess they're called chins, not sidebars. I'm getting the two different helmets mixed up. So I'm going to be working on a mount to put these into the helmet that can make it easy so you can take them out if you need to, if you just want the normal helmet, or if you want to mount them permanently, just glue them in. And then I'll also be working on the, these are the EKG things that are going in the earpieces on the sides of the helmet. And those circular parts. Here's the other side. So they're two different pieces that I have to do. So this is the left ear? No, this is the right ear. And this is the left ear. This is the controller for the volume meters, these guys. And this is the controller for everything, but it's just grabbing power off this one. This one controls the actual fans, the rainbow-colored fan lights. They get plugged into these connections here. Eventually, I will get a better camera. I just don't do video stuff that much, so at least on my computer. So I'm stuck with the old camera. So I apologize to the 3 people who are watching this right now. So I'm gonna get started on designing the blades. You can probably hear in the background my 3D printer running. I'm actually printing some test parts for these fans. I've modified them. Move this stuff out of the way. I've modified them so that left side. I just mirror it so that I can see what it looks like as a whole piece. Delete those. So I've modified these fans based on the first version I printed, so that when you glue them together, you can get the curve right. And I put in these little blocks in between these parts here, so that when you glue the fronts here, right, the edges is basically where you glue it. So I line all the plastic up so that the edges are where you glue stuff together, and you don't have to print all this plastic in here. And I wanted the inside to be angled so it matches the other ones correctly. I'll just go through that. So I added these blocks in the back so that when you glue the front, you can push the backs together and glue those together, and then you get the curve just right. So depending on what version of the helmet you have, whether you have the Voplin one or the Firewire one, or whatever one you buy, or if you have a 3D printer, you can actually download these parts once I'm finished with them and print it yourself. I actually do have, I'll pull the window up for it. I actually do have on Thingiverse the Thomas helmet, which I've uploaded. So they all print in pieces that you can fit on a normal size printer, and then you either glue or zip tie or screw, whatever you want to do to assemble it. Once it's assembled, I went through and I put on glue and smoothed it out, and then I'm going to go and paint it, sand it, paint it, sand it, paint it, sand it, paint it, sand it, and so on until it's nice and smooth. Eventually get it chromed. I won't be chroming it for Halloween, but I will chrome it eventually, but just too expensive. So I'm going to be working on the mounting brackets for the sidebars here, and I gotta measure them. Some people may notice that this helmet looks a little bit different. I guess the bottom chin part of this helmet is a little bit longer. This should actually be, this bottom part should be up here on the helmet. I don't want to say bad design, but I made it a little bit longer so that it fits my large head. The version I upload, I'll just basically connect all these pieces together and then just select the bottom half and shrink it up and repair it so that it looks correct. And I wanted to be able to fit all the electronics in here properly, since there's a lot of room. I might, the version I will upload will be fixed. The one I'm working on is just for my own personal reasons. And if anyone's interested in getting that one, I'll upload both if I need to. But I will upload the fans separately, so anyone who has an actual Daft Punk helmet and doesn't want to make these things out of cardboard or some other material, if they have a 3D printer, they can print them. They print flat. So, I don't want to move those around. Thankfully, it doesn't mess with anything. So, they do print flat. I designed them to print easily on a printer. You don't need support material for these. Depending on your printer, you might want support material just for this gap here, but a good printer should be able to get that centimeter gap. It's not very large. And you won't be able to see it because it'll be behind a tinted plastic. So, wow, I keep moving those around. So I'm printing these. These are probably going to take an hour and 30 minutes, so probably 2 hours with the estimates because it's an ETA. Go back to Maya and let's get started. So I'm actually, these are the measurements that I got from Alex. It's basically 60 by 60, which I think is the measurement. I actually think it's a little bit taller than that. I'll grab my calipers and we'll confirm that. So they're actually 49.5 high. So that's how high they are, and I believe they are actually 60. I might have just not have entered in all the numbers yet. Yeah, they're 60. So it's 60 wide, and I don't think it's quite 2.5 millimeters thick. It's actually 1.5. So there we go. And we're gonna put a band in here about 10 millimeters up. So I'm actually gonna remove my rotations on these so that I can work on it. This is just fantastically fast with all that's going on my computer right now. So 10 millimeters up, we'll center this on the grid so I can work on it. So like this. And I know some people who use Maya may be screaming right now, like, oh, there's tools you can use to do that, but this is how I like to design in very literal. Not literal, So that's 10 millimeters up. That's right where the edge of the LEDs and the circuit board at the bottom is. And I'm basically going to extrude back for the Max 209 chip, or what is it? Max 7219 chip, which is just an LED matrix controller that he used for the chin guards. And that goes up, how many millimeters? 21. Do that. Make this 21. And, you know, it being 3D printed, I don't have to be perfectly exact with everything that goes on here, because people cut the wrong piece there. Mainly because 3D printing, people's printers are all different and print at different resolutions, and people have sandpaper so they can fix it themselves. It just needs to be close so that it's, you know, works on many variety of printers. So that it goes up to a few millimeters to something that's about 12 millimeters for those top 3 bars, or 3 rows of straw hat LEDs. So 12 millimeters. And this is just to have like a rough design inside Maya so that I know where I can place things, and that comes down just a little bit. So I know where I can place things to build the actual mounting brackets. So this is the rough design. Back in this mode. I normally get better frame rate out of Maya, but I think it's just because I'm using Wirecast and I have the YouTube stream going to watch it. So I'm going to pull these out, and these come out 7.62. right there. So I'm basically going to extrude this out. So these are those LEDs, basically the square LEDs for the volume, or not the EQ meters. And then the straw hats come out. Oh, I gotta add the. Actually, gonna stop the stream over here. I need to get some better. So I need to go back to the side view, cut face, add that. And this gets extruded 7 millimeters, right? No! 4.5 millimeters. So there's the bottom. And then there's a circuit board on the back that comes out roughly 4 millimeters. So extrude that. And that doesn't fill up the whole back, but since there's a wire back there, I don't want to crush the wire, so I'll just actually design around having that gap. There's also a capacitor back there, just above, right here, the cap. Not sure if I should... I probably should. Okay, so... Object mode... View. So it's right about here is where the cap is, and I'm just going to freehand this because it doesn't technically matter. It also depends on how you assemble your boards or whatever you use. This is actually for the Alex Plus LEDs upgrade kit for the chins and earpieces on the Daft Punk helmet. I'm not actually doing the matrix display on this helmet, mainly because of cost and time. I don't have time to finish it, but I will add the mounting brackets for the matrix display. So if anyone is going to be doing that, I will be building those, just not anytime soon. So this actually pops out 18 mils. So yeah, that works, and it comes up about 3 mils. So this is the gap where the cap is going to be capacitor. So nobody vomit. I know what I'm doing is wrong, but I'm not actually going to be printing this part. It's just for reference. So I know that there's 2 panes of polygons underneath that, and it does that. But whatever. This is just my reference. So there's the board model. There's also some resistors on the front in this area. So I'll just pull this out just a little bit so that I know that. There's where the resistors are. They're not that big, but... So there's the actual board that I can use as my example. Let's see here. So now I need to build the actual frame that's going to hold these things. Delete our reference. So this goes right there. Rotated. And it sits ever so slightly on that edge. The right one here. But not the whole thing. So right up there. Center our windows here. Oops. Alright. So yeah, I'm seeing a problem here with my helmet being this long, is that I will have a substantial gap right there to make this match properly, because there's missing LEDs. He doesn't fill in the last 3 in this corner over here because of the curve of the helmet. So if I actually put that where it's supposed to be, I have this really large gap, which is what is here. So my measurements are correct. I made this a little bit longer because I have a longer or larger head, I guess. Yeah, 3D print looks fine. This is the worst plastic I have ever bought, and I use it just for fast prototyping because I want to get rid of it. I don't want to throw it away. It's not red. It's like peachy flesh tone, and it's from some company in China that used to be good, and then I guess they changed their manufacturer or whatever. So here, I'll actually show you what's going on. Cut to the camera. So I can show you. So it's with the one on the and you can see how the is really white. Well, apparently hot end melts and disintegrates and evaporates, or whatever it does, the pigment out of the ABS plastic. If it's sat in the hot end too long. I have the hot end turned off as soon as it's done printing, so I think it's just that period it kind of destroys it. So it's just off. So if I was ever printed anything for this that I wanted to like have and keep or give to somebody or sell to somebody or whatever, I'm not using this plastic. And it's not red. It's like orange, peach. Yeah, it's gross. We'll cut back. You can actually see the Guy-Man helmet over there. I also printed a frame for the shell, or for the visor that you can use a heat gun with. Just put that back. You can use a heat gun to mold your own plastic visor. So basically I need to make a mount. And my helmet has screw mounts, which you can see here. So that I gotta actually avoid that part of the design, but still make it usable in other helmets, which I don't have for reference, so I can't make it perfect. Yeah. So let's get started. Well, I've already started, so I'm just blabbering now. Let's see here. Whoa. So this mount right here shouldn't be an issue because it's right on the corner where those LEDs are missing. So if I bring it up just a little bit, I won't move it in, but it should be okay where it is. Yeah. And there's a plastic film that goes over these two, so I'm actually going to make sure I have room to slide that film in. I'll probably build like a slot mechanism so that the film can slide in and be held in front of the LEDs. But then everything's got to really match up perfectly. It's basically just a red strip at the top, right here, that shows where the max of the EQ is, and then there's an orange strip that's a little bit thicker, and then there's the green strip where all the normal lights light up, and it looks like EQ with the bouncing LEDs. So yeah, I think that's actually pretty good. Everyone else's helmets will actually match up with the top parts, so I won't build parts that connect to the fan blades or other parts of this, because I'm going to readjust this whole part up. So it'll actually be up here, so that it lines up with the fans, and it'll actually be correct. Just mine's longer because I want it to be longer. But there's plenty of room to make that happen. So the final one I upload, I've already explained this, so I'm not going to talk Alright, so I'm going to hide everything I don't need. The sides, and that, I need that, and that. Didn't put my screws in. So I only need to make one side, because they'll be glued connected in the middle, and this way you can print the whole part on a 3D printer. 6x6 is what I designed for, mainly because mine's 6x6, and I want to make really big things that don't fit on my printer, like helmets. So we'll actually use our top view for this. I'm going to rotate around just so it makes sense for my brain. My grid disappeared for some reason. Oh, that's weird. There we go. So, we will start with a cylinder. And in Maya, when you put down a cube, it's 1 by 1, and this grid is 1 millimeter by 1 millimeter. But when you put down a cylinder, it's 2 millimeters by 2 millimeters. 2 millimeters by 2 millimeters. So I resize cylinders to be 0.5, and then I freeze the transforms for it, so that resets its transforms to back to 1 millimeter. So I can actually say I need it to be 10 by 10 by 10. It's now 10 millimeters by 10 millimeters by 10 millimeters. So if you are designing in Maya and you're trying to find ways to make things good for 3D printing, that's a good trick to know. I'm sure there's a way you can change the default size for the cylinder, but I do a lot of projects in this, and I'd rather not change all the settings, so that when I go from machine to machine to machine using Maya, my settings aren't different on those machines because other people use those machines. So, I'd prefer to keep my settings or preferences for Maya the same. I do have some plugins, but plugins don't affect people's regular work. So we'll use this cylinder as our. I'm actually not going to use a cylinder. I'm going to use a pipe. So I'm going to make a pipe. I'll shrink it. I will freeze it. And I will grow it. And the pipe is going to get me my curve, so I don't have to manually make a curve. Most things that you would make in 3D, or that I make in 3D, follow basic primitive shapes with just minor changes. It's kind of how I made the chin part here. Is I just made a cylinder, and then looked at a bunch of photos and repositioned the lines, then smoothed it, and then deleted some more lines, smoothed it again to get that final curved shape. 3D printers will print the polygons, so if you don't get it super smooth, you will see that in the final piece. So the final print, so I'll show you the face mask that I modeled with, that's pretty massive. Get out of the way. So for the visor, I actually had to print. I made the visor part, and then I smoothed it all out with. Where is it? Anyways, I smoothed it all out using a tool in Maya, not Mudbox. But I had a really high polygon one, then I increased the smoothing, and then smoothed it out again, increased the smoothing, smoothed it out again. And once I had this really high polygon one, I selected all the faces, and then extruded it inwards. And since it was all square and perpendicular, there weren't any weird flipped normals or anything, it all came out square. And the edges are nice and smooth. And then I just added the mounting brackets where you either add zip ties or glue, and came out with this nice smooth object. So when this prints, it prints out really smooth. Now if I used the really low poly one, that was smoothed in Maya. When I printed it, it would be very jagged and you'd see the polygons. So you have to make sure your object is as smooth as you can get it before you go to 3D printing. It just will take slightly longer to slice the final print. I mean, in this one right here took... Well, let's screw it up. So I started the slice at 11:54, and it finished at 11:55. So it took about 2 minutes in that time, or 11:56. So it took about 2 minutes to slice. Or right now, it says it took a minute, but its estimates are never correct. So I didn't really follow what I just told you for getting smoothing, but these aren't going to be really seen, so I don't have to worry about them being seen. So you'll see that there's polygons on the edges here. Let's see it better in this one here. So when I export things from Maya using the plugin that I got that makes STLs, it doesn't smooth the object, but after I upload this to Thingiverse and then someone downloads it, it looks fine. So it must be something with my STLs before they get converted that shows how the normals are messed up. So you can see here I didn't smooth out or make very many polygons here. It's very low poly. But if any of these things are, this vertex is pulled out a little bit, you'll see that triangle in your final print. So if you want something to look smooth, you need to smooth it. We'll hide our visor and we'll go back to working on this guy. Put it back. So now we're going to adjust our cylinder here. Since we already have all the settings for it, I'm going to increase that just so I can get the shape I want. Change the thickness. And since I made it so small and now I've scaled it up, all these numbers are a little off, so I'm actually going to do 0.1. 2, 3. So that's pretty close. Keep that. Yeah, because the outside edge here will line up, so I'm actually going to shrink this down. So the outside edge will attach to the inside. This is going to be a flat plate with some parts jutting up to hold it, because it doesn't need to be really structurally sound, because the whole frame of the helmet is the structure. I apologize if I'm really quiet. I will adjust my shitty little camera here to sound better. Get it closer to me, I guess, without interfering. How's that? Where was I? So, since the frame holds the structure, this is just going to be glued, or it's probably going to be glued in. It friction fits inside the Thomas helmet for the matrix display holder, so that doesn't need to be really... I put a little bit of hot glue just to keep it in place, but it doesn't need to be held in that well. And since your face is in the way, if it fell out, it's just going to fall into your face, so, ow. But this one will probably be glued in. I use epoxy. Basically, it's use it to repair like lawn chairs and stuff. It just bonds ABS and PVC and a bunch of different plastics. Basically, if you find an epoxy that you want to use for ABS 3D printed parts, make sure it says ABS on it. Otherwise, when you put the epoxy on, it'll seem like it sticks, but after it hardens and dries, it'll just pop off like paint. But if you get ABS epoxy, it bonds with the ABS on a chemical. It's basically a chemical bond, and it works really well. It's way better than ABS paste, basically acetone and ABS. I don't use that because I live in a condo, and having acetone fumes floating around inside are probably not the best idea. So now we only need a quarter of this. So I'm going to delete the rest, but first I'm going to leave the subdivisions where they are because I have to adjust this. It's basically just going in here and I'm actually not going to delete the faces quite yet. I want to get this center line. I want an edge there. So 51. 52. There we go. I'm failing. So delete half. And delete that. So now we have our bar. And we can go back to our normal settings and we can make its Y scale. Let's see, 5. Let me go back here. Here's our bar. Lower that down. And now what I did with the Thomas helmet was I basically used the mold that I made, or the model, very generic model, and I do this for a lot of 3D printing because it's just quick and easy and it works. I don't do it as a permanent step, but I do it as the last step. So I save a separate file that's called whatever the thing's called /print or -print. But I actually Boolean these objects in here. So I will scale this up in the X and Y axis. I don't know. Oh, I have the transforms set to world. There we go. So I will scale it in the X so that when it booleans it, it's boolean a little bit extra space for this to slide in and then just be tacked with hot glue. But the final project I actually will just leave as is, like this. Let's say this is what I'm done with. I'll leave it like this so that if I need to come back and make adjustments, I haven't ruined the whole thing by booleaning a bunch of things together and having a lot of vertices to work with. Now I can actually move this around and put it where I want it to be, and then adjust something on it, and then re-boolean it, export it, and print it. So it makes going back really easy. I'm actually going to get this down to just a plane rather than a full geometry thing, so that I can adjust it and not have to worry about doubling my work. So I will go into face mode and delete the bottom half. And now I have some panes. Now this does need to be printed flat, so I can't up and down adjustment for this, but I can move in and out, or in my X and Z axis, but my Y axis I don't want to really mess with anything. Now when you print stuff, the bottom here, so up and down that you see on the screen, is the Y axis, whereas on the printer, up and down is left to right. So you can see there's a little X, Y, Z thing in the corner down here. So Z points to the right, Y goes up, and X goes in the red direction. So now this direction, so it's to the right. So when I have to export these things, I have to rotate them 90 degrees and put their flat side towards the Z axis, going deep into towards the blue. So now I'm going to rotate this because it needs to match the curve that I have fairly well, but doesn't have to be perfect. Oops. See, that looks pretty good. It's almost spot on. Sometimes I surprise myself. I need to center this. There we go. And for the love of God. Need to remember to save. I do save a lot, but sometimes I will forget to save for hours on end. And Maya will just decide to crash and explode, and everything I worked on will just be gone forever. Which sucks. So this will get printed flat. Basically the bottom side will get printed flat. And this will probably get glued to the underside lip on this piece here. So I'm actually going to center pivot. There we go. So I can get this a little bit lower. There we go. And now we can go into our top view and we can readjust our vertices so that they line up where I want them to line up. I'll leave this inside curve alone mostly. I might push these in a little bit, but the outside curve of this piece, I'm going to try to match up as close as I can to the underside. So just pull these in. I'm not going to touch the inside because I need to have room for the glue. And I do run into this problem here. I do need to have room for glue and different size helmets and basically some wiggle room. This is how I designed the chin piece. Let me know in the comments if the 3D printer is overpoweringly loud compared to what my voice is. I'll probably watch this afterwards and see what it sounds like, but I don't want to get my headphones out right now. And this is the first time I've done a live stream, and I'll eventually get a better camera and a better microphone. But I want to see how well YouTube streaming works before I took the plunge into a bunch of money. So since these pieces, these mounting brackets are there, I'm going to stop designing right there because I'm not sure if I will keep these last two panes. I will bring these parts in because they don't need to stick out as far as they do. I'll actually just straighten them out so they're next to this part here. Grab these two. Oops. Okay. So again, this part's just a bracket. Not going to actually see it outside of the helmet. I mean, oops, I need to keep that parallel. It's just meant to hold some parts, so it doesn't need to be that pretty. But I do try to make things look, good when I can. I'm also on a time constraint. I gotta get this done, or I will have nothing to wear on the 30th. So that looks good. It looks very similar to the one that I made for the Thomas helmet, curve. So now what I do is I go back into my 3D view, and oh my god. So this so that happens sometimes. There's a simple solution. We just do that. And then rotate. Ta-da, problem solved. And it should still look pretty good. Yeah, that matches. So it was doing that because in this mode, you can see the green is not in the yellow square, because earlier I had switched out of world mode for my tool. So now it won't mess up the curvature. So we need to keep this piece flat. It doesn't matter what goes up. So the actual bracket that holds this piece in place doesn't need to be flat. It just means the bottom part that I'm going to print needs to be as flat as possible so that it prints without any support material. Because some people don't know how to use support material. I do, and I will make a tutorial at some point that shows how to use or set up support material within Repetier. I just call it repeater. There's no R. Repetier. Whatever. I don't know how to do it inside the MakerBot, so don't ask me. Because because I don't have a MakerBot. I have a PrinterBot LC. It's kind of old. So now that I have that basic shape done, I can extrude it and make it a thick piece. So basically just extrude and move it down a little bit. And it's my extrude, so -4 mils. Make it pretty thick, substantial. Bam. We have a bracket. And you can see all that time I took to put in that space for the cap, completely wasted because it won't actually put the bracket through there. So what I'm going to do is I'm actually going to put, I'm going to leave it kind of the way it is so that there's a flat part that gets printed into the object that this rests on, so you get that orientation right. And then I'll also extrude some polygons up to create support brackets. I'm not going to go all the way to the top because it'd be a very thin and flimsy piece to print on, and my printer probably could do it, but not everyone's printer can do it. So I need to make it so that it holds stuff at an angle. So I'll put a little angle bracket in here that holds stuff, and then just flat shims on the back. I do tend to open up, at least on the other one that it worked well. Make sure this part over here is open so that this. I'm just going to leave that window open now. So that this can just slide into place and stop. So it's easy to assemble, and it's not this weird, oh, you gotta fish the wires through here and then solder them back on. It's just easy to put together. So people aren't, horribly annoyed by my design. Just checking something. So I've got about 12 minutes left before I'm going to stop. I just wanted to film a quick hour of me designing, so I'm actually going to try to get this done in that hour. I did have a lot of talking. I am kind of windbagging, but I thought I can't just sit here in silence. I got to actually be talking, so there's something to listen to and give some advice. I'm going to go back into world mode. So now I'm going to lay down some lines on here that's going to hold this bracket, and I just do it freehand. Because again, it just needs to hold it. I might just boolean it now because it's fairly simple. Yeah, I think I might. I'll just push that in a little bit. Yeah, I'm gonna boolean it as is. So we'll move into. This way you can see how I do it. So I'm going to hide the chin. So we just have this. And now I'm in object mode. Let's break this off and move over here. I will freeze the transforms of this because this is where I want to keep it. So now its 0 position is where it needs to be. And I'll duplicate, slide it off, and this goes into a parts folder. And the parts folder just has all my design parts. So this is all the fan blades. These are subdiv proxies. Basically, this is the original, and then the fan blade that's actually rotated around on the outside of the helmet, or on the inside of the helmet, is just referencing this original. So this allows me to remodel it without having to reposition it. So it's kind of I can keep my positions correct for everything and where everything's lined up, and I can go in here and adjust vertices on demand and say, I want to move this a little bit over so that it matches this edge. And that's how I designed that part. It also allowed me to extrude things using simple XY directions rather than having to freehand it on the helmet. So that'll eventually go in the parts section, but not right now. So now this is going to get extruded. Oh wait. No, undo here. I actually need to keep this direction here. I'm going to duplicate first and hide it so that I can get back to it. But this is just my Boolean piece, but I need to Boolean in a direction, but I need to be even and not weird lopsided. So we'll expand it a little bit that way, and a little bit that way. And to do a quick check of your part to make sure that you don't have any holes in it, I just hit the 3 button, which smooths it out. And since I've been doing this for a while, I'll see weird geometry issues. So if I were to delete this face over here, I'd see, okay, this should be a straight line, and then, oh, okay, so there should be a face here, and I just double-click on the edge, say fill hole, and bam, now it's clean. So I'll do that to things. I also have to do, especially if I'm Boolean, screwed. I'll select my parts and go up to Display, Polygons, Face Normals, and as long as the normals are facing out, which you can see here, they're not. These edges should be facing out. This one's fine, but this one down here is not. So this would have caused some problems with Booleaning, cutting things apart. So to fix that, I go to Normals and Reverse. And now my normals are facing outward, so this is okay to be Booleaned. This does cause problems when putting on these brackets, because occasionally during my designs, a normal will get flipped, and it'll cause everything to not work. Basically, just frustrates me. So I go back in here, turn off my face normals. Now I should be able to select this, and then select this. Go to Mesh, Booleans, Difference, and bam, look at that. Got a part hole. Now I'm going to Display, Show All. And it's going to show me everything, because I don't know how to put things into groups. I do, I haven't done. Not count and hide. Huh. Anyways, so now that I have that part, you can see here I have a gap on the back, there's a gap on the front, and there's gaps on the sides. So now it fits. Now what it doesn't fit is this lines up right up to the edge, so I'm actually going to move this guy up a little bit so that there's room for you to put a little bit of glue in there. So this edge lines up there. Keen observers would notice that this isn't very good geometry, because if I smooth it, it's gonna, buckle in bad areas. Luckily with 3D printing, it doesn't care. I can just do a cleanup on this and hit print, and it'll print fine. So I don't have to follow all of the principles of 3D modeling. But now I'm going to cut this this back part out. So what I'm going to do is I'm going to remove the face on this, so I don't have to do that. Remove the face on that. The face on that. Remove that face. And that one. And that one. Hell, we'll just remove that whole one. And this one too. And so this does take some time to make look perfect. We'll just, so as long as my bottom part stays flat, I can do whatever I want to the top and it'll be fine. We'll merge those vertices. And we'll go back to world mode. That's what's going on here. Yeah, I'm just going to delete the vertexes. Bam. Ta-dow. So, we'll do this. Extrude. Extrude. And actually, I think there's an easier way to do all this. Actually, I don't think I'll be able to undo far enough. No, I won't. So we'll go back. Up until there right now. And we'll just duplicate that. And go back to object mode. I'm cheating, I know. It's cheating. Cheating. I'm cheating. Oh, it still worked. It's not cheating. I swear. Let's do that. So, there's our final piece. I'm going to clean up this area here and over here so that basically it slides in easily. Now, why did it do that? Ah, right, because of the resistor thing. So, I'll actually make this whole channel smooth, so this piece right here won't exist, and it'll just go straight across. So it holds it, and then I'll do the extrusion for the mounting brackets. I'll probably not upload that as a video, or I could just keep going. I don't have to end it too. I wanted to, but I don't have to. Yeah, yeah, let's keep working on it. Why not? Nobody else got anything to do. It's a Sunday. So let's clean this sucker up. Let's see your vertexes. Make sure we're not. God, that is weird that that happened. Vertex merge. Strange. Very strange. The oddities of 3D printing. Delete edge and vertex. There we go. It's a little cleaner. Let's see. Modify center pivot. I'm going to flatten this out so it's a little easier to work on it. It's pretty flat. Yeah, close enough. Alright. Now I can work on the top and bottom vertexes without any issues. Vertex, vertex, vertex. These ones are going to get deleted. But I can't do that, can I? No, I can't. Why can't I? Ah. That's fine. There we go. Now I'll do the same thing here. So what you can do is you can slide it in, and then you just have to lift the resistors. Pop the camera view on so we can see what I'm talking about here. Let's get this out of the way. Side by side. Well, that's not correct. Source B, eyesight. So, this gets slid into this part here. So over on this edge here will be the resistors next to my thumb. So basically you'd slide it in and then you drop it in. to that section. I'll go back to just regular full screen view. So that part gets slid in there, and this is like a locking mechanism, we'll pretend. This area right here doesn't actually need to be that far out. So I will go back into my 3D view and slide that in. I think that's pretty good. Might move this in. It's about there. So it fits. So yeah, here's a nice base for you to put a glue to hold that particular part. Sorry, my hand is in front of the camera and it's trying to autofocus on nothing. So we turn this back on and flip this back to 0. So when it slides in, this front part is enough space for all those standoffs from the solder posts, and then there's room for you to clip the resistors around this edge here. We'll go back into this mode and do this so that I can figure out why the geometry is doing that. I'm going to clean it up a little bit. Oh, it moved my screen. So split polygons. Just throw a couple edges in here to make the mesh topology a little bit better. Still something weird going on there. Face. There we go. So it's not necessary. I like things when they're clean. Just make the world seem like it makes sense. Yeah, I got a topology issue there. So I can do that and then see it correct. Topology issue there. One solved. So I mean, I'm never gonna print looking like this. Kind of looks like a crab. But now I need to add the support posts. So we'll go back. Zero this out. So there's our bracket piece. My face doesn't get close enough to hit this, but I did want to keep some of this bracket sticking out so that when I do get the matrix for it, that I can just easily modify this bracket and add supports and slots for holding it without having to redo the whole helmet. So, or just go in here with a Dremel and add a slit and then just re-upload the fixed design. But I'll do that for now. Let's see here. Now we need to add our brackets. And I believe if I go into face mode, and yeah, so I'd have to put it on normals. So got to think about this because it's going to print. This is up, basically where the yellow arrow is pointing. So if I did something that went straight up like this, it's going to have an overhang, and I got to make sure that that prints okay. To solve that, I might do a triangular method so that I take both of these vertices and have them go up to hold this, but I have them shrink in size so that it's kind of like a pyramid going up the top. So that way, it's got built-in support materials, so if someone's got a really, really bad printer that just can't handle overhangs of any kind, at least this will print well and not frustrate the hell out of them, because it sure as hell frustrated me when I got my printer and it wasn't set up properly. And I had to set it up myself. I do, because there's no LEDs here, there's nothing to rest on this other than basically nothing. I probably will put in a piece just raised up so that the LEDs kind of sit on that, because there is room for it. Oh no. Oh, I just wasted an hour designing the wrong part. Well, it happens. So I'm not going to worry about that, because these resistors and this cap are actually over here. This part is backwards. It should look like this. Lulz. Well, everyone got the general idea. Yeah. How can I remedy this problem that I have caused? Shit. Live TV. Yeah, I was designing for the right chin on the left side. Shoot. Well, you know, it might not be a problem because there is... the wire connection is right here, and that does help that I do have that large space so that the wire can come out, because the wire... I can basically just remove this bracket here. Oh, but there's a solid plane. So if I remove this part so that the wire can go, I'll have to cut that face. Solving problems. Making it work. It all sounded great in my head. What the hell just happened there? Oh my god. What the hell? Oh, it hates it. I'll just delete it. I can just extrude from the edge. So... how do we make this work? Yeah, so because I was looking at the wrong one, it would have made sense the way I was making it. But because it's the wrong, it's the left chin I need to design for, not the right one. I think what caused it is I was looking at two different views. Whatever. Because the shape of the part is different, my little ledge and hopefully a way to hook it on and hold it in place won't work. It basically just needs to be a slot. Because there's going to be a large piece on this side that takes up a whole lot of space, and then it's really small on the inside. So I can't put... Yeah, there won't be anything supporting this area over here. It'll just be about 4 millimeters of plastic. 4x4, because it's 4 thick. Shoot. Okay, well, if I duplicate group and mirror, that's right, that just happened. So that's what the final part would look like. I'll go in and I'll modify this and just clean it up a little bit. When I do a stream, probably, I might do one tomorrow. I got a lot to do. Not at the same time, it'll probably be about 7 p.m. Central. So, anyone misses it, the video will be on my channel. Please subscribe. I'm going to try to do these things on a regular basis, at least the live streams. Videos themselves, if I get enough subscribers, I'll start actually uploading videos that have some well thought out content. This is just me winging it and opening up Wirecast and streaming. But I hope some people... Sorry about that. I hope some people learn some things from what I did, that mistakes happen, even to people that design cool shit. Shit happens. If you want to follow me on Twitter, I do post a lot of photos of progress shots on this. They also go to Facebook if you don't like Twitter. So the Facebook page is it's facebook.com/Benjamin Dagger. So, and that's Dagger with 1 G. And it's the same thing on the... you can actually find my Facebook profile, my Twitter profile, the Thingiverse page, and my website, all on my YouTube channel page. So thanks, 3 people who are watching. I'm gonna call it quits because I'd rather not sit here and bore you all with me remodeling the same exact thing we just watched for an hour, because I'm going to have to. I'll just revert back to the save I made a few 20-30 minutes ago, which had the actual shape, and clean it up, and I'll post some photos. So thanks everyone for watching. I hope you enjoyed my crazy rantings with shitty audio quality and really low bit rate or frame rate. Yeah, I'm gonna stop talking. Thanks for watching. Please subscribe. Bye.